In this lesson, we're going to look at adding and subtracting radicals, and these radicals are going to contain variables. And in this part, we're going to be looking at radicals that are considered like terms. Okay, so let's go ahead and kind of review something from a previous lesson and previous opportunities that you've learned. Okay, so number one, let's suppose we had 4 times the square root of 3 minus 5 times the square root of 2, and then plus square root of 3, and then plus 2 square root of 2. Now remember, in previous lessons and previous practice problems, you were told basically to, in this case, to perform the indicated operations. So let's go ahead and write it like this. Perform the indicated operations. Okay, now when you did this, remember we talked about like terms, and I'm going to underline, see where you had the square root of 3? So I'm going to underline this term. Now I want you to notice that, or remember that like terms are terms that have the same radicals, all right? And what I mean by that is this. So your index, if they're like terms, the indices have to be the same and the radicand has to be the same, okay? So like terms, the indices have to be the same, so square root, and then the radicand has to be the same. So the radicand here is 3. So if you notice that this term and this term are like terms. And so when you do this problem, you basically, and you can consider this 4 as a coefficient of the square root of 3. So, or so basically you said I have 4 square root of 3's, and then I have 1 square root of 3. So when I add those up, when I combine those like terms, so those are like terms, when I combine them, I get 5 square root of 3. And then when you look at this one, so I'm going to put 2 lines under here. So you see you have a square root of 2. I also have a square root of 2 here. Now in this case, I have negative 5 of them. So negative 5 square root of 2's. And I'm adding that to a positive 2 square root of 2. So when I combine those like terms, negative 5 plus 2 is a negative 3. So I get negative 3 square root of 2. And that's the answer you would write. Now, if you want to, you can also remember addition is commutative. So if you want to, you can put the square root of 2 first. So you'd say negative 3 square root of 2 plus 5 square root of 3. So those are equivalent expressions. All right, so that's what we mean by like terms in previous lessons. Now, if you look at number, that's an equal sign here. So if you look at number 2, let's say we had 4 cube root of 7 minus 6 cube root of 7 plus 2 square root of 7. All right, so I'm going to just see if you remember something from a previous lesson. So if you look at number 2, it notice you have cube roots and square roots. Now, so that means that remember, like terms, you have to have the same index. So this is cube root, this is cube root, this is square root, and that's the only square root I have. So I cannot combine this with any other like term. So this will be by itself. But if you look at this, where you have the cube roots, are these like terms. So remember, like terms, you have to have the same index and the same radicand. So they're both, the radicands are both 7, the indices are both 3's, and so I can combine those. So these are like terms. Even though this is the radicand 7 as well, that's not like terms with anything else because of the index. The index here is 2 and not one of these. Okay, so all I can do is just combine these two. So 4 cube root of 7 minus 6 cube root of 7. So 4 and a negative 6 is a negative 2. So I get negative 2 cube root of 7 plus 2 square root of 7. And that's all I can do. And so those are not like terms anymore because even though the radicands are the same, the indices are different. Now, if I want to, I can put the square root of 7 first. I could say 2 square root of 7 minus 2 cube root of 7. Okay? So either one of those is fine. All right, number 3. Now, in number 3, This is something you had in a previous course. So if you have 7x plus 2y minus 3x plus 5y minus 5x. Now remember, there are no radicals here, but I just wanted to remind you something about something from a previous course. So some of those are like terms, some of those are not. So if I look at the x here, I'm sorry, the first term here, I have 7 factors of x. Over here, I have -3 of them. So those are like terms. These two are like terms along with this one as well. So I have 3 like terms in terms of the variable or in terms of the factor x. So 7 and a -3 is a positive 4x, and a positive 4x and a negative 5x is a negative x. So I get negative x here. And then for the y's, I have 2y and 7y. Those are like terms, so I get plus 7y. Or if I want to, I can put the y first. Does not matter. I would say 7y minus x. Okay? All right, now, before we go on and talk about adding, subtracting radicals that contain variables, and what I mean by that, you see how numbers 1 and 2, there were not any variables involved? Okay, so now we need to talk about, well, what if there are variables involved? Well, before I can do that, let's kind of review some things or talk about some ideas here. So the following examples are considered like terms. So these are like terms. Okay, so these would be considered like terms. Okay, number 1, the square root of x, comma, 2 square root of x. So think about our discussion that we had with numbers 1 and 2. So these are like terms. These are like terms because the indices are the same. They're both square roots, and the radicands are the same. This is x. This is x. Okay, does not matter about the real number that's on the outside. Okay, what matters is in these cases the index has to be the same and the radicand has to be the same. So those are like terms. Number 2, 4 square root of 3x, comma, -2 square root of 3x. So those are like terms. The indices are the same, square root, the radicands are the same, 3x, 3x. Now before we go on, remember, when talking about like terms, you must make sure that those radicals are simplified first. And in our examples, they will be. So they have to be simplified first before you can discuss whether they're like terms or not. All right, number 3. Let's suppose in number 3 I had this. The cube root of y, comma, 4 cube root of y. Those are like terms. They're like terms because the indices are the same, cube roots, the radicands are the same. So those are like terms. Number 4, let me put number 4 here. Number 4, 2x square root of 5, comma, 3x square root of 5. All right, now, let's talk about this. So this looks kind of different than this, right? Because in the first 3 examples, the radicands contain the variable. Here, my radicands do not contain the variable, but there's an x as a factor in those expressions. So that's where we need to kind of talk about something a little bit different now. So these are considered like terms, and they're considered like terms. Now listen carefully. So remember right here we said and we call this coefficient. The coefficient square root of x is 1. Here it's 2. Here it's 4. Here it's -2. Here it's 1. Here it's 4. And when I've talked about that coefficient, we talked about it in terms of a number. So when I look at this coefficient, let's say, is a 2. This coefficient, let's say, is a 3. So what you consider is everything else. So if I look at this part here, in terms of radicals, these would be considered like terms because first of all, the indices are the same. They're both square roots. The radicands are the same. They're both 5s. Now that extra variable that you see as a factor on the outside of the radical, those have to be the same as well. So x squared root of 5, x squared root of 5, so those are like terms. Okay? So if I were to add them, if I were to say 2x squared root of 5 plus 3x squared root of 5, if I were to do that, I have 2 x squared of 5s plus 3 x squared of 5s. So altogether I have 5x squared of 5s. Okay? All right, number 5. 2x squared times the fourth root of 3x, comma, negative 3x squared times the fourth root of 3x. Those are like terms. First of all, just like with these, the indices have to be the same. They're both fourth roots. See the fours? And the radicands are the same. They're both 3x's. Okay? So we know these. We'll go ahead and highlight it just to kind of show you. So these right here are the same. So our idea of like terms in terms of radicals are okay so far. But then I see an extra variable in there. So then we need to look at this now. So when you look at this, okay, that's an x squared. This better be an x squared as well. And so the radical part are exactly the same, and the variable part that's not part of the radical is the same. So therefore, those are like terms. All right. And then remember, you just consider this as 2 of these and a negative 3 of these. So if I were to, let's say, add those up, in other words, listen carefully. If I were to say 2x squared fourth root of 3x plus a negative 3x squared fourth root of 3x. Okay, so if I were to add those, remember these would be what you'd be looking at. So that is exactly the same as that. So 2 plus a negative 3 of them would be a negative 1 of them, right? So the answer would be negative x squared times the fourth root of 3x. And that's all that is. Okay? All right, so let's look at examples that are not like terms. So not like terms. So let's look at this. Not like terms. All right, not like terms. All right, so number 1. The square root of 2x, comma, the square root of x. Those are not like terms because well, first of all, the indices are the same. So that's not the issue, right? They're both square roots. But the issue is the radicands are different. So this is 2x, this is x. All right, so those are not like terms. The radicands are different. All right, radicands are different. Number 2, the square root of x, comma, the cube root of x. All right, so the radicands are the same now, but what's the issue? The issue is that the indices are different. This is square root, this is cube root. So the indices are not the same. Okay, so the indices. Number 3, the cube root of 3y, comma, the square root of 3y. Again, the radicands are the same. The issue is the indices, cube root, square root. So the indices are different. Number 4, 3x square root of 5, comma, 4 square root of 5. All right, so remember what we talked about here. So keep that in mind. Keep that in mind when talking about number 4 here. If you look at the radical part, so I'm going to go ahead and kind of circle this part here. So the radical part, that's not the issue, right? They both have square root of 5s in them. But remember in our discussion here, you got to pay more attention now if there's an extra variable involved that's outside of the radical, like we had here. Okay, so notice this term here, this variable expression, the first one, has an x. It has an x. So if those are to be like terms, then this better have an x as well, and it doesn't. And so those are not like terms of the fact that there's an extra x here and there's not one here. So we're going to say both terms don't have the same factors of x. Okay, so both terms don't have the same factors of x. All right, number 5. Let's say we had this one, number 5. We had 3x times the 4th root of 5x, comma, 2x squared times the 4th root of 5x. Okay, all right. So first of all, look at the radical part first. So the radical part is this, the 4th root of 5x. I have the same thing here. So we're good so far, right? Now look at the variable factors that's outside of what I have circled. Here I have 1, see, x to the first power, so here I have 1 factor of x, and here I have how many? 2. So those are not the same for the same reason as this. So both terms don't have the same factors of x in this case. So both terms don't have the same factors of x. Okay? All right. So just to remind you, they would be like terms. They would be like terms if I had something like this. 3x squared, 4th root of 5x, comma, 2x squared, 4th root of 5x. Oops, sorry. So you see how this was x to the first, and so this was x squared, so those are not like terms anymore. But if they were both x squareds, based on our discussion before, then these, see how these are the same? So all you do is whatever operation, whether you add or subtract, you would use 3 of these and then 2 of these. All right, so those would be like terms. All right, and then number 6, suppose you had 2x squared, square root of 5x, comma, 3x squared, square root of 2x. So what's the issue there? Can you think about the issue is? Now, those are not like terms. I'm telling you, they're not like terms. But can you right away figure out what the issue is? Okay, so the issue is not the x squared, right? The issue is the radicand part, and the issue is not the index either, both square roots. But the issue is the radicand part. This is 5x, and this is 2x. They're not the same. So here, the radicands are not the same. Okay. All right. Now we know what like terms are, and we know what terms that are not like terms look like, right? Okay. Now let's do some examples. So this is going to be so the directions will say something like this. The directions will say perform the indicated operations. So perform the indicated operations. All right, perform the indicated operations. And sometimes it may just tell you add or subtract, but remember, add or subtract is an operation. All right, now there are going to be some variables involved. So remember in one of the lessons a while back, we talked about taking a square root of a variable raised to a power. Sometimes we talked about absolute value. And then after that point, we always said assume that all variables represent positive real numbers. And so that way you don't have to worry about the absolute value. Okay, so let's look at number 1. Number 1, you have 6 square root of x minus 2 square root of x. All right, so first of all, are those like terms? The answer is yes, because square root, the radicands are the same. So all you do is do the coefficient part. So 6 square root of x minus 2 square root of x is 4 square root of x. And so that's how it looks. Number 2, 8 4th root of y plus 3 4th root of y. Are those like terms? Are these two terms like terms? Yes. fourth root. The radicands are the same. They're both y's. So 8 of these plus 3 of these equals 11. Fourth root of y's. Okay. Number 3, you have 14 square root of x minus 6 square root of x plus square root of x. So this time you have 3 terms. Are all 3 alike? Yes, they are. Square root of x, square root of x, square root of x. So I have 14 of these. I have and you're subtracting 6 square root of x. So at this point there are what? 8 of them. And then 8 plus 1 square root of x gives me 9 square root of x. Number 4, you have 8 square root of y minus square root of x minus 12 square root of y minus 3 square root of x. All right, so obviously you can tell that all 4 are not like terms. They all have square roots, right? But the radicands are different. So let's look at the first one. So I have a square root of y here. Is there another term? Is there another term somewhere that's like it? Yes, it is right here. So 8 square root of y subtract 12 square root of y gives me negative 4 square root of y. So I get negative 4 square root of y. And then these right here would be like terms because they both have square root of x. But here I have a negative 1. This is a negative 3. So a negative 1 square root of x plus a negative 3 square root of x gives me a negative 4 square root of x. And so you can write your answer like this, or if you want to put the square root of x first, this term first, you can. You would say negative 4 square root of x minus 4 square root of y. Okay? Does not matter. Okay, number 5. Now, number 5, let's suppose in number 5 we have 12 cube roots of x plus 3 fourth root of x minus 7 fourth root of x plus 11 cube root of x. All right, now be careful here. The radicands are all the same. They're all x's, the radicands, but the indices are different. Some is cube root, some is fourth root. All right, so let's look at this one first. Let's look at this term. I have a cube root of x. Is another term, do we see another term with a cube root of x? Yes, right here, right? So, and that's it. All the others are fourth roots. So let's look at these two. So these two are now like terms. Those are like terms. I have 12 cube root of x's plus 11 cube root of x's. So 12 plus 11 is 23. So I get 23 cube root of x, right? Okay, now let's look at these right here. Those are like terms because they're both fourth root of x. So the indices are the same, the radicands are the same. I have 3 and a negative 7. So 3 and a negative 7 is a negative 4. So I have negative 4, fourth root of x. So be careful, make sure you put the correct index. And if you want to put the fourth root of x first, you can, does not matter. You would say negative 4 fourth root of x plus 23 cube root of x. Does not matter because remember addition is commutative. The order in which you add does not matter. All right, let's look at number 6. Number 6, you have 7x cube root of y, 5, minus 2x cube root of 5. All right, now let me remind you this. So in all the previous problems that we did, numbers 1 through 5, notice the radicands all contain the variable. Here, remember, notice that the radicand does not, but there's a variable involved. So that's where you got to remember this idea here. Okay, so those are like terms, though, right? Those are like terms, and those are like terms because the radicals are the same, and that now that you see that variable, so I have x, one factor of x here, x to the first, and I have one factor of x here, x to the first. So those are like terms. All I got to do now is just combine 7 of these and a negative 2 of those. And so 7 and a negative 2 is a positive 5, x cube root of 5. And that'll be the answer there. Okay? All right, let's look at number 7. Number 7, let's suppose, at number 7, we had this. All right, number 7, we have 5x squared, fourth root of 3x, minus 12x squared, fourth root of 3x. All right, first of all, I have two terms. Are they like terms? Yeah, they are, right? Because I have my radical's the same, fourth root of 3x. And then if you look at your variable now, I have an x squared and I have an x squared. So those are good. So then all I got to do is look at the negative 5 and the negative 12. So I have 5 x squared cube root of 4x and a negative 12 x squared fourth root of 3x. So 5 and a negative 12, what's that? Negative 7. So I get negative 7 x squared fourth root of 3x. Okay. Now, so let's. I just want to, before we do the last one, let's look at this one first. If I have 2x squared square root of, let's say, 3y plus 3x square root of 3y. All right. So I have two terms. The radical part's okay, right? But are those like terms? Are those like terms? Yes or no? No, right? Because if you look at this one, this right here has two factors of x, and this right here only has one. So those are not like terms. So, but you got to answer the question. So the question was, remember, perform the indicated operations, right? And so perform the indicated operation. So what you would do here is just say cannot be simplified. So you just say cannot, can't, or cannot be simplified. Just say something like that. All right. And then depending, if this is multiple choice, they may have this choice over. So you would just rewrite this over. But just for right now, just put cannot be simplified. See, all the others you could simplify. I simplified this operation to this. So I simplified this into this. I simplified, let me find another one real quick. I simplified this to this. I simplified that to this, and so on. Okay? So just put cannot be simplified. Now, if you want to put cannot be added together, you could, but just write cannot be simplified. Number 9, okay, final one. Let's suppose we had this. We had 2x cube root of 4y, that's 4y, plus 3x squared cube root of 4y, minus 5x cube root of 4y, plus x squared cube root of 4y. All right, so looks like a lot, but think through it. It's not difficult. So I want you to notice though that in terms of the radicals, they're all the same. Cube root of 4y, cube root of 4y, cube root of 4y, cube root of 4y, right? But they also all have variables. Some have different factors of x, and some have other factors of x. So I want you to notice this right here. So consider this one first, right here. I have, remember, they're all the same. So all of them have the cube root of 4y. But this I have one factor of x. Do you see another one with just one factor of x? See, that's two factors of x. That's two factors of x, but here you have one, right? So do y'all agree that this and, let me see if I can find it, then this are like terms? Okay, so those are like terms. So that means then all I need to do is just add 2 and a negative 5. And so when I add 2 and a negative 5, I get a negative 3x cube root of 4y. Okay? this and this becomes this. Now let's look at this one. So this has x squared. So do y'all agree that this right here, that this x squared, 2 factors of x, I have the same amount of here, right? And so then all I need to do is add 3 and 1. That's a 1 here together. So that becomes 4 x squared cube root of 4y. Right? And again, if you wanted to put this term first, you could. You would say 4x squared cube root of 4y minus 3x cube root of 4y. Okay, either one is fine. Okay, all right. So that should take care of this part where we were adding and subtracting radicals containing variables, and then those were dealing with like terms. All right.